Greetings everyone. Today we are going to explore multiplying matrices. You do want your handout for this. It just makes it a little faster. If you don't have it, jot this down in your notebook. Alrighty, let's start off by going over a few multiplying rules. To multiply matrices, the number of columns in the first matrix must equal the number of rows in the second matrix. We've already discussed dimensions of matrices, so writing these out will make that process way quicker. Second note is that matrice multiplication is not commutative. You're used to saying 2 times 3 is the same as 3 times 2, but with matrices, it doesn't work out that way. So whatever order you're told to multiply in, you must stick to that. Let's use these dimensions here to see if we can multiply. I have a 2 by 3 matrix and a 3 by 2 matrix. The number of columns in the first matrix is equal to the number of rows in the second matrix. So here's visually, I write out the dimensions and I say, yep, those match. And here's the really interesting thing. The number of rows and the number of columns end up being the dimensions of your new matrix. So if you write the dimensions in order, this is a trick, if the inner numbers are the same, you're good to go. And the outer numbers become your new matrix. So let's explore how this works with actual matrices. So in example 1, I'm going to list the dimensions first. This is a 2 by 3, and we're trying to multiply it by a 3 times 2. Okay, so check columns and rows. The inner values are the same, so that's good. Our resulting matrix is the outer values. We should arrive at a 2 by 2 matrix. And so something I like to do is set up the blanks of what I'm looking for. Now I'm making these a little larger because I'm going to show you the work as we go. So to multiply, you're going to go row by column. And so here's how I look at this. Look at this spot right here. I would say that this is top left, right? In my little new answer matrix, top left. That means I care about the top row and the left column. You have to go row by column, okay? So top row, left column. So here's how I'm going to show that work, okay? We're going to take matching pieces and multiply them, meaning I'm going to say -3 times -8. I'm going to take 2 times 1, and I'm going to take 5 times 0. Do you see how I did that? First value, second value, third value. So we multiplied. Now we need to combine those, right? I need a single number. So to combine, that means adding. So here I'm going to have 24 plus 2 plus 0. So the final number I need is 26. All right, let's try the next one. Again, I like to use sort of where is my blank space. This would be top right. So we care about top row, right column. I'm going to take the first pieces and multiply them. I'm going to take the second pieces and multiply them. And I'm going to take the third pieces and multiply them. And we're going to add them together after we multiply. Oops, that should be a -15. If I make a silly calculation error, please excuse me, it's bound to happen with mental math. What do we got here? 4, I'm getting -11. Let's take a look at the next. I would consider this area to be bottom left. So I care about the bottom row and the left column. Now this time I'm going to try to show less work, right? I'm going to multiply right away. 7 times -8. 1 times 1. 0 times 0. See how I just showed a little less work? So we've got negative 55. Let's take a look at the last spot. The last spot, I would read this as, let me find a different color here. Bottom right. Bottom right. Do you see how I'm using that to help me think this through? I'm going to just multiply right away. 7 times 2, 1 times 5, 0 times negative 3. We combine our multiplication pieces to get the final value. Now, I don't need to see all this work. I don't need to see the labels. My hope is that you can take care of at least most of the mental math, maybe have a little bit of sketch work, and then a final answer. Because the goal is my final answer would just look like this with 4 numbers, 26, negative 11, negative 55, and 19. Alrighty, let's take a look at the next example. Let's list the dimensions first. This is a 2 by 2 and a 2 by 3. Check, we're good to go here. This becomes the dimensions of my new matrix. So I should have a 2 by 3. 2 by 3. I always like to prep first. I feel like I'm less likely to make mistakes. And so let's take a look. I'm going to try to show a little less work on this example. Top left. Top left. 2 times 3, negative 1 times 5. That gets me a positive 1. Let's try the next one. Top middle. Top middle. 2 times negative 9, negative 1 times 7. Whoops, that's not 7. Oh my goodness. Negative 25 there, Mortfit. All right, let's take a look at the next. Again, I'll likely make silly errors, so you just fix, all right? Top right. Top right. 2 times 2, negative 1 times negative 6. 10. Next, we're moving to the bottom. Bottom left. 3 times 3, 4 times 5, combine. Next, bottom middle. Bottom middle. 3 times negative 9, 4 times 7, combine. And my last spot would be bottom right. 2 times 3, 4 times negative 6, negative 18. So my final matrix is just those single numbers. You don't have to show me work, or your work could be outside of the matrix if you'd like. That's up to you. All right, let's try this one out. Check the dimensions first. This is a 2 by 3. This is a 2 by 2. Uh-oh, those don't match. That's not good. I can't multiply them. Now, let's say you don't check the dimensions, okay? So first of all, can't multiply. Let me just stress, I can't multiply this. And so when you can't multiply, we need a more mathy way to say that, right? And so we're just going to say undefined. I can't, whoops, my pen went crazy there. I can't do anything about what I'm being asked to do, so we're going to say it's an undefined problem. All right. Now let's say you don't do the dimensions. Let me stress how this might happen. If I was like, oh, top left, right? Oh, 6. Oh, negative 27. Oh, I ran out of numbers. Like, what do I multiply the 2 by? So if you don't do the dimensions, what's going to happen is it's not going to work. You're going to run out of numbers or have too many numbers. And so without dimensions, you'll just know. It just won't work. You can't multiply these. All right, if they're square matrices, that automatically makes it easier, right? 2 by 2, 2 by 2, we're going to arrive at a 2 by 2. So much easier when they're the same size. Kind of like adding's easier when they're the same size, right? Just, it all flows better. So top left, I'm going to try without the circles, okay? Work with me here. Top left, 0 times 4, negative 1 times negative 2. Top right, 0 times negative 3, negative 1 times 5. Bottom left, 1 times 4, 0 times negative 2. Bottom right, 1 times negative 3, 0 times 5. Now, if you thought, well, that was easier with those zeros, that's for a reason. We're going to revisit sort of these patterns with zeros and ones. When you have zeros and ones, something unique happens, so expect it to look interesting. All right, let's try this weird one. I am definitely talking about the dimensions here. This is a 3 by 1, and this is a 1 by 2. So we have these two small matrices, right? And check, I can multiply them, but look at the dimensions. My final matrix is going to be a 3 by 2. 3 by 2. I am going to draw circles for this one. It's very unique. Top left. There's only one set of numbers, you guys. You barely have to think about this. It's just negative 15. Top right. Multiply them. There's no adding because there's nowhere to go to. Middle left. Middle left. Middle right. Middle right. Bottom row. Bottom left. Bottom left. And bottom right. Bottom right. So even though it ended up being a much bigger matrix, it really wasn't too bad. So again, I can't stress enough that multiplying matrices is not commutative. You have to follow the order you're given, left to right. And you have to do one set at a time. What does that mean? Let's say I tell you to multiply matrix A times matrix B times matrix C. You're going to have to multiply these first. That'll get you a new matrix, and then take that one times C on the right side. See how I drop down the first two, drop down the right, and multiply again. So be very careful, especially in some of your homework problems you might see. All right, so just to bring up a couple other points, these aren't in your notes. And if we take a look here, sometimes we had an example where we had small matrices that became a large matrix, right? In this case, I kind of have two larger matrices, but watch what happens. If I do the dimensions, a 1 times 3 versus a 3 times 1, oops, sorry, a 3 times 1, there we go. I can multiply them, right? But look at the resulting matrix. Sometimes it's just one number. Don't be thrown off by that. Because if I take top row, left column, look at how that is, right? That would be 1 times 4, negative 3 times negative 1, and 4 times 2. So look what happens there. We just get a single number. So don't let that throw you off, okay? That can happen. You can have a single cell in your matrix. Also, let's take a look. This bottom equation, this is an example of what I previously said, how it's not commutative. So let's say I ask you to take A times C times B. That means you would take A, oops, drew a line there, sorry about that. You would take matrix A, and you want to go in order, so then you'd multiply it by C. Now I'm not going to actually do the math on this, I'm just making it up. You would get a resulting matrix, right? 2 by 2. But then you have to take that B matrix and drop that down, and it has to be on the right side. It has to be on the right side. So you have to take your resulting matrix times the B matrix. So watch out for that, okay? It needs to go in the exact order that you have, and you have to work left to right. Alrighty, that's our lesson on multiplying matrices. If you're struggling with sort of the process or the moves of this multiplying, it's I almost use my hands when I multiply on a worksheet, and just like top row, left column, left column. I constantly try to decide what row times what column. And there are other videos out on YouTube that are great at showing that without circling, or maybe they have a document camera to show it better. And so just consider, if you are struggling with this topic, please, please, please seek out other videos, or let me know if you want me to send you some other video links, okay? So seek out other videos. There's so many good ones about matrices out there, okay? Let me know if you have any questions. If you're here at Legacy, check out the Saber Center. You've got those math teachers listed. They can all help you out. And until next time, I hope you have a good one.